A list of equations is given. Use the list and inductive reasoning to predict the next equation and verify your conjecture. Well, first thing, when we look at this sequence of equations, we're going to notice a few things. We have 11 times 12 here, 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 and here. So that occurs in all four equations, which means that we should conjecture that 11 times 12 will occur in the next sequence of equations. Then in the second sequence of equation, or the second equation, we have 11 times 144, which again occurs in the two subsequent equations. So we're going to add that in because we can assume that that particular pattern will follow through. Then we look and we see this next term, 11 times 1728, and that occurs in the next subsequent equation, so we can assume that it will occur in this following equation, the fifth equation that we're trying to create. Then we notice that there is this 11 times 20,736. Since each previous equation includes, or I should say the last term in each previous equation gets included in the next equation, it is okay to assume that it will be included again. Now, the problem is what is the next term that I need to come up with? Well, when we look at this, if you look very carefully, you'll notice that 12 right here times 12 will be equal to 144, which occurs right here. And then if you take 144 and multiply it by 12, that will be equal to 1728, which occurs right here. And if you multiply that by 12 again, you will get this next term of 20,736. So logically, it makes sense that the next time I need to come up with a term, I'm going to take this value of 20,736 and I will multiply it by 12. And that will be equal to 248,832. So since the 11 continues to occur in every single term, and I don't need to highlight every one of them, it follows logically that 11 will occur in the next term in this new statement that I'm creating. So I'll have 11 and I will multiply that by my new value of 248,832. Now, what is this going to be equal to? Well, if we look back at each of the subsequent equations, we notice that 12 occurs in each step. So it follows that this will be equal to 12 times something. And then you'll notice that here we have 12 and here we have 12. Here we have 144, here we have 144. 1,728 occurs here, likewise 1,728 occurs here. And then 20,736 occurs, and likewise 20,736 occurs. So it makes logical sense that the next value that is going to go right here is going to be the exact same value as this. So it'd be 248,832, and you'll notice that throughout this entire sequence we are subtracting 1 from each subsequent value, so we will subtract 1. And then we need to confirm that this is a true statement. In other words, does the left equal the right? So then we will punch all of these numbers into the calculator and we will come up with an answer. So I'm using an online calculator entitled web2.0calc.com, and you will see that the web address for this is contained on the page that I'm at, which is right here. And this is an excellent calculator to use. I use it all the time when I'm working problems. So let's go ahead and type in everything that we see here. So first we'll start with 11, and we'll press the multiplication key, or we can use the asterisk key on our keyboard. We're multiplying by 12. We're adding to that 11 times 144, adding to that 11 times 1728, adding to that 11 times 20,736, adding to that 11 times 248,832. And then you'll notice that across the top, as you punch these numbers in, that they occur just as we've written them across the page. So we'll press equals, and we have an answer of 2,985,972. So let's go ahead and write that down. And now we need to go ahead and verify that the right hand side is also equal to 2,985,972. So we'll clear this, we'll type in 12, and we will multiply that by open parentheses 248,832 minus 1, close parentheses, left click equal, and you'll see that we get the exact same value of 2,985,972. And so we'll go ahead and write this down over here, and just to confirm that that's exactly what we have gotten, and we'll put that in a different color, 2,985,972. So I've had to use inductive reasoning to get from one step to the next step, and I have to look for a pattern that's occurring. And really what gave it away when you first start looking at this is going from this first line to the second line, because it's easy to see that 12 times 12 is 144, because that is a perfect square. And then you have to continue that process.